Hello, this is Mrs. Ross, and this is Lesson 5, Place Value Through Hundred Trillions, Reading and Writing Whole Numbers, and this is the starred problems. These are the starred problems from the written practice on page 38 of your Saxon Course 2 book. Okay, so let's decode this. Number 1 says, what is the sum, and I know that's an addition problem, of 607, so that's 607 and 2,393. So I have 2,393 and I have 607, and I'm going to add those two. And I get 3,000. Okay. Number 2 says use digits and other symbols to write 100, 1,000. So this is 101,000 is greater than 1,100. 1,100. So when you see them written out like that, it makes a little bit more sense. Number 3, use words to write 50,574,006. So this is 50 million 574,006. Okay. Number 4, which digit is in the trillions place in this number? So I have my hundreds, my thousands, my millions, my billions, and these are my trillions. So the 2 is in the trillions place, the 1 is in the 10 trillions place. So the number is 2. Number 5, use digits to write 250 million, 5,070. Okay, this would have been easier if I had done it the way that I did it in the practice set. So these are my hundreds, these are my thousands, these are my millions. 250 million would go right here. 5,000 would go here, and I'd know that I have to fill this in with zeros. And then 70 would go here, and I'd have to fill that in with a 0. Okay, number 6, replace the circle with the proper comparison symbol. That means greater than, less than, or equal to. Then write the comparison as a complete sentence using words to write the numbers. So negative 12 is greater than negative 5, because if you remember on the number line, you know, here's my 0, here's negative 1, here's negative 2. The further I go this way, and negative 15 is going to be over here, and negative 12 is going to be up here. The further I go this way, this is less than the negative 12. So we'll make the monster eat the negative 12, and then we'll write it out. So negative 12 is greater than negative 15. All right, number 7, and I'm going to change colors just because I'm tired of red here. Arrange these numbers in order from least to greatest. Keep in mind our number line up here. So I have 0. I'm trying to find the least, the number that's the least. I think it's negative 7, so I'm going to start with that. And then do I have any other negative numbers? I have negative 1, so that'll be my next greatest. I have no more negative numbers, so it's going to be 0, and then 4, 5, and 7. Okay, show this subtraction problem on a number line. I didn't upload a number line before we started. Again, I'd like to reiterate that I'm not a fan, but I'm sure hoping that, oh, we don't need negative numbers here, I don't believe. Either way, okay, so we start at 0, and we're going to go to 5. Okay, and since it's 5 minus 4, subtraction goes left. So we have 1, 2, 3, 4. And my answer would be 1. All right, number 10, find the value of each variable. So the first thing I'm going to do is multiply all of these. So 2 times 3 times 5, which is 6 times 5, which is 30. So what I have for number 10 is 30n is equal to 960. 30 times n is equal to 960. So I have to do the opposite of multiply, which is divide. So 30 divided by 30 is n. My equals comes down, and 960 divided by 30 is 32. Okay. 11. So 11 is a subtraction problem, and the variable is in the first spot. If it's in the first spot, we add. If it's in the second spot, we subtract. Second and subtract both start with s. So here I'm going to add 1367 to this side, 1367 to this side. This is going to go away. I'll have my a is equal to, let's see, that's 7, 6, 8, 3. Let me change colors here so we don't get confused. All right, number 12, we're going to go ahead and add this first and see what we get. So let's do number 12 here. So b plus, let's see, 17 plus 5 is 22, I believe. Yep. So b plus 22 is equal to 50, and this becomes just a regular unknown addition problem. Okay, so right now we're adding and we're going to subtract. Remember, addition and multiplication are super easy. You do the same thing every time. It's division and subtraction where you got to put that extra step of thought in there. So b is going to come down. 22 minus 22 is nothing. And then we get 8, that's 4, 28. Okay. So let's look at 13. 13 has $25 minus k is equal to 1870. So my variable is in the second place, so I have to subtract. So I have 25 minus 1870. And I get 630. And that is my answer. Okay, let's try a different color again. All right, 14, 6,400 plus d is equal to 10,000. It's an addition problem. I'm always going to do the opposite. So I'm going to subtract. This is going to go away. My d comes down, my equals comes down, and I get 3,600. Okay, and last one on this page, number 15, I have 144 divided by f is equal to 8. So when my variable is on the bottom, I divide. So 8 goes into 144, let's see, once, that's 64, 18. So f is equal to 18. Now when my variable is on the top, I multiply. You'll want to have those rules in the back of your spiral. Number 27. Which property can we use to find each unknown number? So here I have 365 times n equals 365. So I haven't changed the identity of the number at all. Hence, it is the identity, property, and since we're multiplying, it would be of multiplication. And here on B, I have 52 times 7 equals 7 times what number? So I know that 52 times 7 is going to equal 7 times 52. So what I've done is I've changed the order. Order is the commutative property. And since we're multiplying, it would be of multiplication. Number 28. Let me get a different color here quickly. Use words to describe the rule of the following sequence and then find the next three terms. So 10 minus 2 is 8, minus 2 is 6, minus 2 is 4. So the rule is to subtract 2. The next three terms, so 2 minus 2 is 0, minus 2 is negative 2, minus 2 is negative 4. Those are my next three terms. Okay, 29. Name each set of numbers illustrated. And you'll see this in mathematics for the rest of your mathematics career when they talk about a set, which is just a group. It's a fancy word for group. When they group numbers, they use, I call these little things chocolate chips because they look like sideways chocolate chips. And then these little dots, they call these ellipses. Fancy word. So what they're doing is they're showing you a set or group of numbers in what they call set notation with these chocolate chips and ellipses. So 1, 2, 3, 4, these are going to be counting numbers. Okay. When I put 0 in front of 1, 2, and 3, these become whole numbers. Whole numbers do not have negative numbers. And then when I have negative numbers, then I have integers. Keep in mind, none of these involve fractions or decimals. Not yet. Use braces. Okay, the brace is the name for the chocolate chip. My bad. Ellipse, which I put up there, and digits to illustrate the set of negative even numbers. So negative even numbers, let's see. So negative 2, negative 4, negative 6. There aren't any negative numbers higher, or negative positive numbers higher, but there are some negative positive numbers lower. So the ellipses tell me that this goes on this way forever. But it doesn't go on this way because negative 2 is the largest negative even number. All right, that's the end of our lesson 5. Please make sure you ask me any questions that you have, and have a great day.